Okay, Algebra 2, last one. Good job. This is the last lesson of the year. Congratulations to all those who have made it through. Okay, so what we're doing here is we are solving equations where the variable is in the exponent, and we're going to use logarithms to do it. Okay, and we can do that if both bases are positive, meaning this number right here would be positive and this number would be positive. If there's a negative in there, we have to do something else. Okay, all right, so here we go. What we can do is, in order to bring this exponent down, we can bring a log into both sides. What you do to one side of the equation, you have to do the other. I just brought a log in here and a log in there. Log 7 to the 3x is the same as, pulling that out in front, 3x times log 7 equals log 20. Now we just divide by log of 7, and then we have 3x equals, and then we can say, okay, divide by 3. Here I divided by 3 times the log of 7. That will work as well. I like taking one more step just to make sure I'm seeing all my work. Okay, I'll take you through a couple of these. Let's go. There we go. Okay, so what do? We're solving for an exponent. This does not have a common base. I can't figure out the common base and then set the exponents equal to each other. So what I do is I bring in logs. Log 3 to the x equals log 4. That allows me to take this x out in front because the exponent also equals multiplication. X times the log of 3 equals log of 4. Then we just simply divide by log of 3. Now, I kind of want to make sure I put the parentheses there because it's really important to put the parentheses when you're using your calculator. Okay, so I'm in my calculator now, and I'm going to go log of 4, close the parentheses, divided by log of 3. And I get 1.26185. 1.26185. Okay, so if I plug that back in, and I have the number right there in my calculator, if I go 3 to the second answer, okay, I just get 4. Okay, if you plug in this number 3 to this, you're going to get like 2.99, or excuse me, 3.99999, something like that. Okay, let's take a look at this one. Okay, what would you do? You'd bring in logs to both sides. Log 6 to the 2x equals log 21. That allows us to take this 2x out in front. So I have 2x log 6 equals log 21. Now, what I like to do is just divide by log 6. So I have 2x equals log of 21 divided by log of 6. Log 21, close parentheses, divided by log of 6, close parentheses, enter. 1.69918, right? Okay, so I get 1.69918, whatever. I have that saved in my calculator. Now to solve for x, I'm just going to divide by 2. Divide by 2, divide by 2, divided by 2. X equals 0.8496, about. Okay, why do I like to do that? Well, if I want to check my work, I can just take 6 to the 1.69918 and see that I get really close to 21. I don't have to go 6 to the 0.8496 times 2 to check my work. I can just check my work from right there and make sure it looks good. Okay, let's slide this over. Here we have a little addition going on there. Okay, again, I'm just going to bring in a log. Log 3 to the x plus 4 equals log 101. Okay, that allows this, and I like to put it in parentheses to go out in front. Why do I like to put it in parentheses? Because we need to make sure that we're taking this as a coefficient of log of 3. because if you don't, you might think that's 4 times log of 3 and then the x out there. No, it's x plus 4 times the log of 3. So now I can just divide by log of 3. Okay, and now I'm in my calculator. Log 101 divided by log 3. Enter. 4.2008 whatever. So I got x plus 4 equals 4.2008. Okay, it should be a 9 probably, so I'll just go 8.6. Okay, subtract 4, right, to solve for x. Subtract 4, so I got x equals 0.20086. Okay, on tests or quizzes, okay, our last test coming up next week, I think, maybe 2 weeks. We will round to 3 decimal spots. That's pretty typical. Okay, so that is one way to use logarithms to solve. Another way is going to involve the change of base formula, which we're going to look at right now. Okay, we've already looked at this change of base, and we did something like this where we had, log base 2 of 5 equals log of 5 over log of 2. Okay, because if we don't have a base in there, the implied base is base 10. Okay, just like a square root, the implied index is 2. Okay, the implied base is base 10, and that's what's on our calculator. That button on our calculator is log base 10. Okay, so we can figure out what that is, and I'll do that real quick. Log of 5 divided by log of 2, and we get 2.32. 322, round to 2 decimals. Good. Okay, so we're going to use that change of base and all kinds of stuff. Take a look at this. If we're solving using this technique, we'll use change of base. Watch how this works right here. If you have the same base as this number right here, these will cancel, and this will just cancel down to equal 7x. That equals 7x. Okay, I'm going to show how that works here. Take a look. We've got log, well, let's zoom it in. We've got log base 5 of 5 to the third. Okay, if I evaluate this using our old school method, okay, take a look. Equals x. What do? Drop it down, kick it up. That's 5 to the third equals 5 to the x. Well, what does x equal? X equals 3. Okay, now we didn't have to do that. We could just go, because this log base 5 of 5, we can just kick that out, drop that 3 down, and we just know that it equals 3. Okay, and we can use that to solve for an equation later on down the line. Okay, it's another way to use logs to solve. Okay, so log base 4 of 4, boom, equals x plus 3, because x plus 3 is in the exponent. So that's just x plus 3. So it's a quick way to bring exponents down into the equation. Okay, so let's see how this would we would use this. Okay, so the one previous, we just brought in logs to both sides, log base 10. Here we're bringing in what the base that's being taken to the exponent. We're bringing in that log base there. So we've got log base 7 of 7 5 to the 5x equals log base 7 of 3,000. Well, this 7 and 7 cancel down and cancel out that log. So we just get 5x equals log base 7 of 3,000. Okay, so people get stuck right here a little bit. But right here, what we have to use is the change of base formula. Big font, log 3,000 over small font, log 7. And we get our number here, and then we divide by 5 to solve for x. Okay, and that we use the change of base formula from here to get our actual numbers. Okay, so a different technique. I'm not a huge fan of this technique. Some people are. It works well. I usually just bring in logs to both sides, but we need to know how to use all our techniques. Okay, so here we go. What are we going to bring in? We could just bring in logs to both sides, but I'm going to bring in a log base 3 to this one. Those just cancel. I just get x equals log 182, right? Now I'm using change of base formula on this right here, okay? Over log of 3. Okay, and I'm going to jump on my calculator here. Log 182, close parentheses, divided by log of 3, close, and I get 4.737. Good? Okay, let's do it a couple more times. What do I bring in here? Very good, log base 7. Log base 7 of 7 to the 2x equals log base 7 of 9. These cancel. I just get 2x equals, now I use change of base, log of 9 over log of 7. Okay, on my calculator, log of 9, close parentheses, divided by log of 7. Enter, and then I'm going to divide that by 2, right? I got 2x equals 1.129, okay? But I have that on my calculator. I'm going to divide it by 2, and I get x equals 0.565. Okay, round to 3 decimal spots. Good. Okay, one more and we'll have a little addition in there. That's fine. We can use that. Okay, I'm bringing in a log base 5. Log base 5 of 5 to the n plus 1 equals log base 5 of 3. These cancel. I get n plus 1 equals, run change of base on this, log of 3 over log of 5. So my calculator can do that. Log of 3, close parentheses, divided by log of 5 equals, okay, and then I'm just going to add 1, but I got subtract 1. Plus 1 equals 0.683, right? And I just subtract 1, minus 1, and I get n equals negative 0.317. Good. A little bit more. Just kind of a long lesson. I'm sorry, but here we go. Last one again. Let's finish strong. Okay. This is a log equation. Okay. So just like we used logs to solve an exponential equation, we're going to switch this to exponents to solve for log equations. And how we do this, take a look. It's kind of sneaky. They don't show us the base of 10. I like to write it in because what am I going to do? I'm going to change this to exponents. How do I do that? I'm going to drop this down and kick this up. That eliminates the log. I get 4x minus 3 equals 10 to the second. So I have 4x minus 3 equals 100. I'm going to add 3 over. Add 3, 4x equals 103. $25.75. And there we go. Pretty cool. All right, let's take a look. So now we just solved an equation with logs in them. Next one. Take a look at this one. Looks really tough. I can never do that. Yes, you can. Take a look. Okay, what do? This addition between these two logs becomes multiplication. So now what I have is log of x minus 3 times x, right? Equals 1. Okay, that's log base 10. Drop it down, kick it up. excuse me, x times x minus 3 equals 10 to the first. Terrible time to start a coughing fit. All right. X squared minus 3x, little distributed property. That's 10, right? So I'm going to subtract 10, set it equal to 0. Anytime I have an x squared and an x in an equation, I set it equal to 0, factor and solve. Factoring x minus 5 times x plus 2. Two numbers that multiply to negative 10 that add to negative 3. There we go. Equals 0. Set these two equal to 0. I get x equals 5 or x equals negative 2. Now, one of these is an extraneous solution. You cannot have a negative number as the base. Okay, so if you plug these answers back in, you cannot get negative numbers in there. Okay, so if I plugged back in a negative 2, I get a negative number in there. So not negative 2 and yes to 5. All right, that does it for the semester. Great job. Thank you for hanging in with me, and I appreciate all of you. Bye-bye.